Alright guys, so next week we're going to have a quiz on the first 4 lessons, 2.1 through 2.4. Well, actually not next week, it's this Thursday, I take that back. So this Thursday you're having a quiz on lessons 2.1 through 4. The study guide here is intended to help you guys get ready for that. The quiz will be modeled after the study guide. And you guys, I'm just going to go through every problem on the study guide, so that way if you guys end up having any sorts of questions, I can help you out. So for numbers 1 through 4, we're being asked to identify the input and the output. Okay, so in function notation, you have to know which variable is the input, which one's the output. So I'm going to record my answers over here. So for number 1, the input is the one in parentheses, so that would be A. The output would be the one on the other side of the equal sign. You could technically also say it's M of A. That would work as well. Number 2, whenever it's written out verbally like that, the one that comes first, C, is the output. The other one is the input. And it works for the other way of saying it as well. If I say E is a function of F, it's still the same. The one that comes first is an output. The second one is the input. As for number 4, when it's written out as an equation, the one that's all by itself on one side of the equal sign, that's your output. The one that's all mixed up with the letters and math and stuff, that would be the input. Okay, so that's identifying input and output there. Now, number 5, similar question here. It says, the number of owl pellets depends on the number of owls. Label the horizontal and vertical axes of a graph with the variables given. So I didn't put any letters on here. So let's say that the number of owl pellets is O, and the number of owls, let's say the number of owl pellets is P. The number of owl pellets is P, and the number of owls is O, right? Well, if P depends on O, if the number of owl pellets depends on the number of owls, that means that this is the output, and this would be the input. And whenever you put something on a X and Y axis, or horizontal and vertical axes of a graph, the output goes on the vertical axis, the input goes on the horizontal axis. All right, let's go ahead and take a look at numbers 6 through 11, it looks like. All right. Is temperature a function of the month? Okay. Is temperature a function of the month? In other words, is it possible for temperature to be an output while the month is an input? Is that possible? Well, inputs can only have one output. So let's take a look at the months here. Do you see how there's no repeats in there? Since none of these numbers are repeated, that means each one of these months goes with only one answer, for the temperatures anyway. So since there's no repeated numbers here, that means each number has one answer, and therefore the answer is yes. Okay. Now let's take a look at the next one. Is the month a function of temperature? So in other words, can temperature be an input? Let's take a look. Are there any repeated numbers here? I don't see any repeats. So yes, every temperature seems to be associated with only one month. So that's also a yes. Let's go ahead and take a look at 8. Is the month a function of sick people? So in other words, can the number of people that are sick be an input? And the answer is no. Because if there's 10% of the people are sick, then we don't know if that would be month 1 or month 4 because both of them have 10%. So this is a no, because the number of people sick can't serve as an input because there's a repeated value in that row. Number 9, is the number of people that are sick a function of temperature? Well, we already set up here that temperature can be an input, so it can be an input here as well. So this is yes. So the only thing up here that can't serve as an input is the sick people, because that's the one with repeats. Okay. All right, let's go ahead and take a look at number 10 and 11. F of 50. All right, so the directions say let f of t equal p, where p is the percentage of sick people and t is the temperature. Okay, so this represents temperature and this represents sick people. So that would mean the 50 is a temperature, and this, whatever goes here, is going to be a number of sick people. So I'm going to find where t equals 50, and I'm going to look to see how many people are sick when that happens, and the answer is 10%. So there we go. Let's take a look at number 11. In this case, we don't know what the t is, but we do know the number of sick people. So I'm going to look for where the number of sick people is 5%, and that I will look at the temperature that goes with that, and the answer is 90. Okay? So that's evaluating tables and knowing how to tell if a function or if a data represents functions or not using tables. All right, let's go ahead and take a look at number 12. For number 12, I give you two functions, g of m and f of m, and I ask you to do a lot of different things with them. So for part A, I ask you to evaluate g of 4. And all that means is that you're going to plug in, well, not 4, negative 4. All that means is you're going to plug negative 4 in to the g function. And the answer would be negative 7. All right, let's take a look at part B. For part B, g of m equals 9, solve for m. So in this case, since g of m equals 9, I can replace g of m with 9, and I can solve for m. Four-thirds. This was evaluating, this was solving, something we talked about a little while back. Let's go ahead and take a look at part C. For part C, we're combining the two functions by subtraction. So I want to find what's f of m minus g of m. Now f of m is 4m minus 7, and g of m is 3m plus 5. I'm going to distribute my negative and just combine like terms. 4m take away 3m is 1m, and negative 7 take away 5 is negative 12. So we end up with m minus 12. Let's take a look at part D. We want to do f of 3 divided by g of 1. So that means I'm going to evaluate f at 3. In other words, I'm going to plug 3 into the f function. The f function is 4m minus 7, but I'm going to replace the m with 3. The bottom means I'm going to evaluate the g function at 1, so I'm going to write the g function 3m plus 5, but instead of m, I'm going to plug in 1. So on the top we have 12, take away 7, which is 5, and on the bottom we have 3 plus 5, which is 8. So 5/8 would be our final answer there. All right, moving on. So, use the graph below to answer the questions that follow. We have two functions on this graph. We have f and g. I'm going to go ahead and color code them. So I'm going to make f this red-brown color here. And I'm going to make g this green color right here. I didn't notice that f has an arrow up here, but a dot here. And the g function has an arrow on the right side, dot on the left. Okay, so let's go ahead and take a look. F of 0. So what that means is I want to look at the f function, the red one, and I want to find where x equals 0 on that red line. So that would be right here. And the answer would be the y value that goes with it. So therefore it's -4. G of x equals -2. So in this case I'm going to look at the g function. And I want to find where the output, the y value, is -2. So on the green line, I'm looking for a dot that has a y value of -2, and that would be right here. And to solve, we need to just find the x that goes with that y value, and the answer is 1. All right, number 15. What's the domain of f of x? Now, domain is all the possible values of x. So, for the f function, I guess I shouldn't put the equal signs yet because I'm not sure it'll be equal. For the f function, the farthest to the right that this red function goes is at this dot here, where x equals 3. But it never stops going to the left because there's an arrow. So you could write your answer like that. Or you could write your answer like, oh, and by the way, since this is a solid dot here, you can have an equals here. But we can't equal -infinity, so we won't put an equal sign on that one. So you can write your answer like this also. Either way is fine. All right, let's go ahead and take a look. What's the range of f? Now, range is about the y values. How far up and down does it go? So the lowest point on this red graph is right here. And that y value is -4. And it does equal -4. There's no holes there. But it never seems to stop going up. It goes up forever. So we'll put infinity here. And another way to write that would be like this. All right, let's do the g function. What's the domain, or the possible values of x, for the g function? The farthest to the left that g goes is -3, and it has a solid dot there, so we'll put an equal sign. But it never stops going to the right, so we'll put an infinity sign there. The range of g, the y values, highest and lowest points. The highest point is right here where y equals 0. But it never seems to stop going down. And it does equal 0, so we can put an equal there. And so we would write it like this. Okay, last two questions. We're going to practice graphing these things. Now, I showed you guys two ways to do this in class. One way was by turning all the points into a table and then using the table. The other way was just working straight off of the graph. So I'm going to do the table method for number 19, and then I'll do the fast method for number 20. But in any event, you should be getting the same answer. So let me clean up my graph here a little bit for this one. Keep the g as a green function here. Solid those dots up real quick. And then we'll also make this red function And the reason I put those dots on there is just so that if you do decide to go with the table approach, those are the dots you're going to use. So for number 19, I'm going to go with the table approach. So with the table approach, we go ahead and we start by listing all the x values of the points that we have. You only need to do it for one of the functions because they both have the same x values. They just have different y values. So for instance, this point and this point, they have the same x value. They just have different y values. So I'm just going to go off of the green one here. The first dot on the left is -3. Next after that is -1 right here. Next one after that is here at 1. And then the last one right here is at 3. Okay? And so now I'm going to give all the y values that go with those x values. So for x equals -3 on the green line, the y value is 0. Oh wait, that's I need to put G there because this is the G line, not the F. Alright, for the next one, when x equals -1, y equals -1. So put -1 there. When x equals +1, y equals -2. And when x equals 3, y equals -3. We're going to repeat that process now for the f function, the red one. When x equals -3 on the red line, the y value is 5. When x equals -1, the y value is -3. When x equals 1, the y value is also -3. And then finally, when x equals 3, the y value is 5 again. Okay. Now, that's just setting up the problem. Now we're going to actually answer number 19. Now number 19 wants us to find f of x minus g of x. And all this means is we're going to find the f value and the g value and subtract them. So f minus g. So f minus g, 5 minus 0 is 5. For the first row, for the first column there. The next column over, f minus g, -3, take away a -1. Watch your math there. Is -2. F minus g, -3 minus a -2. Double negatives make a positive, and we end up with -1. And then finally, f minus g, 5 minus a -3, is 8. Okay, so we have now all of our points. Okay, so for f of x minus g, we have the following points. When x is -3, that's this number here, the y value for the combined functions is 5. Next point, when x equals -1, the f minus g value is -2. When x is 1, the f minus g value is -1. And when x is 3, the f minus g value is 8. So we're going to plot those 4 points and connect the dots. So -3, 5. -1, -2. 1, -1. And then 3, 8. And if I just connect those dots, I would get something that looks like that. Okay? So that's the long way to do it. Now the shorter way of doing it is instead of making this whole table, all you have to do is take the y values of the 2 points that are vertical from each other and do whatever the problem asks you to do. So in this case, it's f minus g. So I would do 5 minus 0 is 5 and put a dot at 5. Okay? Or for these pair of points, it would be -3 minus a -1, and I would get -2. I'd put a dot there. So all you have to do is combine the y values the way that the problem's asking you for each pair of points that are vertical to each other. Okay, so now I'm going to use the faster method to do number 20. If you don't like my faster method, you can still do the table. You should get the same answer, but here we go. So for this one, we're going to combine the y values by multiplying them. So for my first set of points, I'm going to multiply their y values. So 5 times 0. 5 times 0 is 0, so I'm going to put a dot at y equals 0. Next pair of points, I'm going to multiply the y values. So negative 1 times negative 3 is positive 3. My next pair of points, I'm going to multiply the y values. So negative 2 times negative 3 is positive 6. So I'm going to put positive 6. My next pair of points, the y values, I'm going to multiply them. We get 5 times negative 3, which is negative 15. So I end up with a point that's way off the chart. So it's going to be way down here at negative 15 somewhere. I seem to have lost this point. Where did it go? With negative 2 times negative 3 is positive 6. It's up here. I know how I lost that. All right, anyway. So it looks like something like this then. Okay? So that's where we'll stop for the day. So I gave you a fast way and a long way to do numbers 19 and 20. Do whatever you prefer. But that should do it. I think that covers the study guide. So there you guys have it. Good luck on your quiz.